Alright, continuing here with logarithms in Unit 2. So this is our third day, first day of logarithms. Something new for you guys.
Section 3.
Chapter 7, Section 3 of the textbook. Alright, so a logarithm, there's your definition there. All that logarithms are for is sometimes it's really hard to figure out what your exponent is when you have an exponential, like on the left there. So what logarithms were created for is so you could find the exponent. So your exponent to y in the b to the y, and on the right in your log form, they solve for y. So you're finding it, okay? And you read this as log base b of x. So
yeah, take a moment to repeat that to yourself and actually say it out loud. Log base b of x equals y. So it's really important to get that terminology correct.
And logs give you the answers. The answer to a log is your exponent, okay? And then all this stuff here at the bottom, all it's saying is we're dealing with positive bases for b, and we're only dealing with positive x's for our answer. So that's the only thing that's saying down at the bottom. Nothing to worry about there.
Alright, so one of the big keys for this unit is to be able to write them in logarithmic form if they're currently in exponential form. And you can easily tell the difference. If it's in log form, you see the word log, okay? So obviously here we're in exponential form. Our base is 10. Alright, so we're going to rewrite it. And our base is always going to be 10. No matter what form you're in, the base is going to be the base. And what I like to say is the base is that'll come later. But anyways, log base 10, and then you just swap the 10 and the 100. So now the 100 is here, and it equals 2. So we would say log base 10 of 100 equals 2. So again, take a moment, repeat that to yourself. The second one, again, our 3 is our base, so it will also be our base in log form, and we just switch the 4 and the 81. Log base 3 of 81 equals 4. Go ahead and hit pause and try those second two. All right?
How are you, Mr. Ritter?
I'm great. How are you?
I'm good.
I'm just doing a screencast. Check it out.
So you're going to be on our lesson.
Yeah. So read that question for us, if you would.
How do you get the form on the left to the right?
Yeah, nice and loud. Did everybody hear that?
No one's in here.
We're recording this for our lessons. Anyways, hey, you got to take a close look at how you get from here to here. Be ready to discuss.
Alright, now evaluating a log. Okay, so what we can do here is we got this change of base formula. We can use logs, or we can use something called natural logs, like on the right in that yellow box. Okay, so this is where we can use the calculator to figure this out. So the log base 81 of 27 equals something. So 81 to some power will give us our 27. So we have to figure out what that is. Now the way we do this is we're going to change it. So the log 27 goes on the top, and we divide it by the log of 81. Alright, so your base goes in the bottom. The log of whatever your base is goes in the bottom.
Base is in the basement.
That's right. Now, this can be done on your calculator. So here's a little shot of what you get on the calculator. You take the log of 27, close the parentheses.
Don't forget.
Close the parentheses, and then you divide it by the log of 81, gives you 0.75. Now it doesn't matter if you use the log button. This is over on the left, natural log. The ln is over on the left as well. ln of 27, close your parentheses, divided by the ln of 81.
Okay, there you go. Either way, just close those parentheses. All right, another example to look at, and again, hit pause and try it out. Go ahead and hit pause and see if you get the right answer. Okay. The last thing we want to cover here is something real quick, just mentioned in passing, but anytime that your base is the same as this, they will cancel each other out and you just get 2. So take a close look at your logs when you see them, and then you'll be able to recognize that.
Yep, this is just, you can use that going from log form to exponential, but you can do this too. The 5s will cancel out and you're left with 2. Same thing with the next one, you're left with just the exponent, x minus 2.
And right here, it's again, we're seeing that the 5s are in common. It looks a little bit different here, but we'll see later on when we talk about properties how that works out. But that cancels and leaves you with x squared. And then right here, we would go ahead and just see that the natural log and the base e are inverses, so they cancel each other. This equals x. Little practice for in the back of the book. To do on your own.